All right, let's just dive right in. We think of physics as this super precise science, right? Full of brilliant minds and exact answers. But what if I told you that at the very heart of cosmology, there's a mistake? And not just any mistake, a prediction so spectacularly wrong it challenges literally everything we think we know about the universe.
And look, this isn't some rounding error. We are talking about the single biggest disagreement between a theory and the real world in the entire history of science. It's this huge cosmic mystery that forces us to ask a really uncomfortable question. Is our entire understanding of the universe just fundamentally flawed?
So to really get a handle on this mismatch, we first have to talk about how science even works. Think of our best scientific theories as these incredibly detailed maps, or maybe like blueprints for how reality is put together. We use these blueprints to make predictions. We say, okay, if our theory is right, then when we look out into the cosmos, we should see this exact thing. And then we point our powerful telescopes up to the sky and we check. It's this constant, crucial cycle of predicting and then verifying.
And you know what? For the most part, these theories are just stunningly successful. They've predicted everything from gravitational waves to the existence of black holes. But there's one prediction, one really crucial part of the blueprint that leads to a massive conflict. It creates a tale of two universes, the one our theories predict and the one we're actually living in.
And this is where our story takes a really sharp turn. This isn't just a small discrepancy we're talking about. It's a profound, system-level disconnect. It's where we realize our map of the universe and the actual territory, well, they don't line up at all.
Okay, so according to our best models, everything we've built on quantum physics, the vacuum of space itself should be just fizzing with energy. The idea is that empty space is this bubbling sea of virtual particles, constantly popping in and out of existence. All that activity should generate a massive amount of what we call dark energy, this incredibly powerful force pushing everything apart.
But when we actually look out there and measure it, that is not what we find. Not even close. Yes, the universe is expanding, but the force driving that expansion is unbelievably weak. The cosmos is strangely quiet, way less energetic than our theories demand it should be. So just how big is this difference? Get ready for this number. That is a 1 followed by 120 zeros. It's a number so huge that our brains can't really even process it. To try and put it in perspective, it would be like if a theory predicted the size of a coffee mug, but when we went to measure it, we found the entire observable universe instead. It is the most wrong a prediction has ever been in the history of anything. This colossal, mind-bending mismatch actually has a name, the hierarchy problem. It's this profound, glaring conflict between the predicted strength of this cosmic energy and the shocking weakness we actually observe. This is the central tension point in all of modern cosmology. So just how deep does this conflict run? Let's do a little side-by-side. Let's put the universe our theories predicted next to the real one we see every day. The clash is just stark. Our theories scream for this high-level energy potency, but reality whispers back with a documented weakness. They expect this perfect alignment of scales, but what we actually see doesn't even come close to those levels. And while our models are built assuming their baseline is correct, the evidence is practically yelling at us that we need to reevaluate the entire logic we're using. And this is exactly where that name, the hierarchy problem, comes from. You've got this hierarchy of values with the massive scale predicted by theory way up at the top, and the tiny, almost non-existent value we see in reality way down at the bottom. The gap between them? Well, that's the whole problem.
So what do you do when your best map of reality is this wrong? It's not just about needing a new map, is it? It's about questioning how you even make maps in the first place. Scientists have a term for this, a methodological crisis. And that basically means the problem might not be with a single equation or a single bad assumption. The problem might be with the entire method, the fundamental approach we use to understand the universe's behavior. This goes so deep, it suggests that our very starting points, the foundational rules we use to define what energy even is, might be incomplete or maybe just flat out wrong. It's a challenge to the very truth that our models are supposed to capture. And you can imagine, this creates huge friction for researchers. They're stuck asking these massive questions. Why on earth do our theories overestimate so wildly? Why do they work perfectly for other cosmic phenomena but fail so catastrophically on this one point? And, maybe the hardest question of all, How do you even test a radical new idea when the old rulebook is so clearly broken?
Now, a crisis like this can seem like an ending, right? But in science, a problem this big, well, that's also the greatest possible opportunity. It's like a giant signpost pointing us toward a brand new frontier.
The hierarchy problem is a catalyst. It's the engine that's driving funding, forcing incredible collaborations across different fields, and inspiring a whole new generation of scientists to search for entirely new ways of thinking about the universe. This isn't an end, it's the start of a revolution.
And really, the stakes couldn't be any higher. As the source material puts it, solving this mystery is the single most vital task for science today. Because figuring out why dark energy is so weak, that could be the key that finally unlocks a complete, unified understanding of all of reality.
So, we're left with this absolutely tantalizing question. What if the biggest mistake in physics isn't a mistake at all, but a clue? A hint that our rulebook for the cosmos is missing a chapter. Or maybe, just maybe, it's pointing to a fundamental law of nature we haven't even dreamed of yet. And finding it, well, that's going to change everything.